The chest measurements of 18-year-old male footballers are normally distributed with a mean of 95 centimeters and a standard deviation of 8 centimeters. We need to A. Find the percentage of footballers with chest measurements between 87 centimeters and 103 centimeters. That's part one. Then we need to do the same thing for 103 and 111. Find the probability that the chest measurement of a randomly chosen footballer is between 87 and 111, which is basically the same question really as part A. And C, we need to find a value of K. K will be a chest measurement in centimeters, such that approximately 16% of the chest measurements are below K centimeters. Now this is going to be done with a non-calculator method, and I'm going to do it using these three key facts about a normal distribution. So 68-ish, around 68%, 68.26% of all values in a normal distribution lie one standard deviation within one standard deviation of the mean. So it could be one standard deviation below the mean or above, but within that range that you have 68% of the values. I will draw a sketch in a minute. 95.44, if you go one standard deviation further, so two standard deviations away from the mean either side, and you've got 95.44% of all values. Then if you go three standard deviations out, you've got nearly everything. 99.74% of all values lie within three standard deviations of the mean. So outside of that, you've only got the real outliers. So if it's chest measurements, you'd have really small chests on the small tail, or someone with a gigantic chest being outside of this 99.74. You really are talking about outliers. So what I am going to draw, well, we know, let's say let x be the random variable the chest measurement of a footballer. I'm not going to put the 18, I just don't have room. If you want to write the chest measurement of an 18-year-old footballer, that is fine. Okay, so we have been told that these chest measurements are normally distributed. So that means X is distributed with a normal distribution. We define a normal distribution with mean and variance. So the mean is 95 centimeters, and the variance is going to be 8 squared. So I'm just going to write 8 squared. You don't really use the variance a lot, but that is how you define it when you write it down. Do not just write the standard deviation in here, it was not correct. So we need to find the percentage of footballers with chest measurements between certain things. But before we do that, we need to draw, it's really handy to draw a sketch. The point of this is to get you used to the symmetry of the distribution, the patterns. You are not expected to learn say you got this in a non-calculator paper, you're not expected to learn this 68%, the 95.4%, and 99.74%. You don't need to learn that, but these principles that I'm going to show you with the symmetry, yes, you do need to know that, because they could always just give you a proportion, and then you could have to work out using symmetry from there. So I'm going to do my best at normal distribution curve, something like that. And I'm going to draw my x-axis there. This is x in centimeters, and then we have any normal distribution is symmetrical about the mean, like that. Right, so this is mu, and in our case we have been told the mean is 95. Okay, and then we know that we've got one standard deviation, 2 and 3. So I am not very good at drawing it. So actually the first standard deviation, so it should be around this point of inflection, but I'm not particularly good at drawing them, so I'm just going to sort of put it here. So I've got to do 1 standard deviation, 2 and 3, like that. So it just missed a little bit, certainly here. 1, 2 and 3. Try and space them out evenly. So you know this is 1, so this is mu plus sigma, this is mu plus 2 sigma, and here is mu plus 3 sigma. So 1 standard deviation above the mean, 2 standard deviation above the mean, and 3. And then to go the other way, well, we need to do mu minus sigma. This must be mu minus 2 sigma, and here 3 standard deviations below the mean, mean minus 3 sigma. And we actually know what those values are. I'll put them in. We have a standard deviation of 8, so we can put all these in, and then you should quickly see that a lot of the values I'm about to write are the values we're being asked about in the question, so that's going to help us a lot. In fact, I might just sort of move these lines down so it doesn't get too confusing. Okay, so the mean we said was 95. And standard deviation is 8, so this must be 103, just add on 8, 111 and 119. We go back the other way, 95 minus 8 is 87, take away 8 is 79, and take away 8 again must be 71. Right, so now we've got all our values and we need to start to answer some questions. So for part A1, so we're looking for the percentage of footballers with chest measurements between 87 and 103. So 87 and 103 is this area here. And you will see that's all the area covered by 1 standard deviation above or below the mean. So all of these values here are within 1 standard deviation of the mean. So looking at the statistics we've been given, that the 3 key numbers, this is going to be 68.26% because it's within 1 standard deviation of the mean. In terms of the geometry, that means this area that I've just shaded is 68% of the total, because remember, this whole distribution, the area under this curve needs to be 1. For any continuous random variable, if it's the whole domain of all possibilities, then it's total area of 1 under the curve. So the answer is 68.26%. Okay, A2. I want to know the percentage of footballers with chest measurements between 103 and 111 centimeters. So 103 is here, 111 is here, so that's this area here. Well, if I just take its equivalent that has the same area on the other side, so we've got this bit here. Well, you know, this whole area, so if I had shaded all of this as in the black area and this, say, let's dotted area here, all of that combined is the area within 2 standard deviations of the mean, which is 95.44%. But we know that the area within 1 standard deviation of the mean is 68.26. So if I was to take the 95.44, which is all of this area here, take away this 68.26, that will leave me with the combined area of these two. And then if I divide by 2, that should give me the area of just one of them. So I need to do 95.44 minus 68.26, and then I'm going to divide that by 2. So I will use a calculator, but what I'm not doing is using the functions on the calculator, which we will see in future lessons. So that should give me approximately 13.59%. I'll stick to the accuracy we've been working with. So that's C2, that's so A2. Now we move on to B. Find the probability that the chest measurement of a randomly chosen footballer is between 87 and 111. Right, so 87 and 111 is, well, it includes this area. So it's from here it's there. So what we're doing, let me just write down, we are finding the probability x is between 87 and 111. And as you should know by now, for a continuous variable, the actual, whether these are less than or equal to or just less, that shouldn't make any difference, because when you're thinking about the actual lines, they're minusculely thin. They're so thin that it doesn't make any difference. But I'm gonna put them in like that. But if it didn't include those numbers, the answer would be exactly the same. Well, if you think about this area, well, it's all of this area within one standard deviation of the mean, plus the answer to the first bit. So it's going to just be 68.26 plus the answer to the other bit. So one of these bits here, 13.59, and that gives us 68.26. That is 81.85%. Which is technically a probability. If you want to convert that to decimal, you can, but I'm not going to bother for this. I think, remember, these proportions, relative frequencies, probabilities, that they're all the same thing, that they all are completely equivalent in terms of theory. Right, part C, find the value of K such that approximately 16% of the chest measurements are below K. So what we're going to do is look at these three key values. So we have 68.26, 95.44 and 98.74. So if you look at the first one, well, in fact, let me just write down what so we're finding P that X is less than K equals around 16%. So 16%. Right, so as I was saying, the 68.26%, that is all of this area here, right? So if then, you know that the whole thing here is 100, and 100 minus 68 is about 32, and half of 32 is about 16. So if this is around 68%, these two tails that are left, once you've taken this bit out, they're going to be around 16% each, because it has to add up to 100%. So if I want it to be below K, I'm interested in this number here, which is one standard deviation below the mean. So this will make it around 16% of the value is lower than that value. So the number is 87. K equals 87 centimeters, and that will work fine.